Hello. So in this video we are going to do LVS parasitic extraction, extract the netlist and do the LVS and then do the post layer simulation. And also we're gonna do schematic versus post layer simulation, the comparison between the waveforms. So here let's do so. When we finish the layout, make sure that there's no DRC error. So select as a box and then type DRC Y. Make sure that there's no DRC error. If there is, then correct the layout. And then let me save it. And then we're gonna first do extract all. And the information is saved in this file, inverter extraction. And then what we're gonna do is just extraction to spice. So it will be extracted as spice netlist. If we go into layout here, it's extracted as this one spice. Let's have a look at this file. Oh, okay. One thing we didn't do is we didn't turn off the scale. Otherwise, it's gonna be width is 100, L is 15. What I'm going to do is I'm going to remove inverter extraction and the inverter spice. So right now only the inverter layout file is saved. What I'm going to do here is do it again, extract all, and I'm going to extract to spice, turn off the scale, which is scale off, and then do the extraction to spice. Now let's look at. So we are interested in this spice. Okay, now we can see that two MOSFETs. It's extracted as drain, gate, source, which is for the PFET, and the parameters here extracted as numbers, not the same as schematic where they are extracted as expression. That is the key differences between schematic and the layout, but here the widths and the lengths are correct. Okay, now we have the layout spice, and then what I'm going to do is I'm going to move the schematic netlist into this layout folder, and then we're gonna do comparison using netgen. So our schematic is this. If we do the netlist here, this is the schematic netlist. I'm going to save this one, save as into our current folder, or we can do on the terminal going to this .xschem and the simulation and the inverter spice. And the one thing is that the schematic netlist also called inverter spice. So what I'm going to do is first let's go to that current layout folder, projects, test, layout. This one is the layout netlist. What I'm going to do here is I'm going to change this schematic netlist as, let's call it Xschem. So this one is corresponding to schematic netlist. Save it. Now we have layout netlist and the schematic netlist. So we're gonna do LVS using netgen. So if you haven't downloaded NetGen yet, please do so first. I have already installed Netlist, so here if I new window EDA tools, so I downloaded this NetGen. So this zip file is available in the OpenCircuit design. If you go to OpenCircuit's website, NetGen, download the latest version zip file, and then extract the zip file, install using this /configure, and I suggest do sudo make and sudo make install to install it. After installation, we just need to type netgen, and it's gonna invoke this netgen terminal, another terminal. Here, because we invoked the netgen from this current folder, so here the same as current directory is inside layout, so we can see the layout netlist and the schematic netlist. So what we're gonna do is just LVS, and doesn't matter the order, just inverter spice, and let me do the inverter schematic first, because it says like circuit 1, it says circuit 1, circuit 2, so that we know that circuit 1 is always schematic and the circuit 2 is always layout. And inverter spice, if I click, okay, so it says couldn't find this setup tickle file. This is the setup file for the LVS. So this one is available inside Skywater PDK. So if you go to EDA tools, open PDKs, if we go to Sky and Sky 130, open PDK, okay, open PDK, and then go to Sky 130 and go to Sky 130A, and if we go to libs tech, from here you can see that we have this netgen folder available. So go to cd netgen, inside we have this setup tickle setup file, so we need to copy this one into the current folder layout here. So what I'm going to do is copy setup and then go to this projects and the test and the layout. And if I come back to here, this tickle file is copied here, and then I don't know if I need to do re-invoke again, but let me try here. So if I ls, we have this one here. Now let's do LVS. Let's do the schematic first. As I said, the order doesn't matter. It can still compare. But for me, let's do the schematic first, and the circuit 1 and the circuit 2 refer to as the layout. So if I click, okay, final result, circuits match uniquely. Okay, that's good. So now we have schematic netlist and the layout netlist are the same. So here, circuit 1 contains 2 devices, which is schematic contains 2 devices, the layout contains 2 devices. Schematic have 4 nets, layout have 4 nets. Let me just quickly look at these 2 netlists again. Oh, okay, so we need to schematic netlist, and then layout netlist. If you look at the differences, so all here are commented out. So we had just um, two devices, and as we already seen, the area of drain, source, perimeter are expressed as here the expression, some mathematical expression, but in the layout it represents as numbers. So these are the differences. So we have LVS is done. If LVS not passed, then you can see that we have this uh, compare results. It's logged into this file comp out and see what exactly missed, and we can change the layout to make them same. Okay, now we need to do post layout simulation. Again, post layout simulation. First, the key is that the simulation first test bench uses. Okay, just remember that the layout, we don't have any sub-circuit here. It's just two devices here. But if we go to test bench, okay, when we run the simulation, usually netlist looks like this, right? So we have some voltage sources and the inverter itself, library, transient simulation, save all the voltages, and we have this sub-circuit. This is the key point. We cannot directly simulate using this one, and also we didn't extract any parasitic capacitances. So first we need to extract the layout as dot subcircuit, and also we need to extract the parasitic capacitances from the layout. So in order to do that, let's go to layout. In order to do that, we need to extract all. We need to turn on the hierarchy so that it extracted as dot subcircuit. So that's going to be extract to spice hierarchy on. And again, we need to do extraction to spice. We need to turn off the scale off, and extraction to spice. So we need to extract some parasitic capacitances from the layout. So that's going to be C threshold 0. That means that all the parasitic capacitance, as long as it's larger than 0, so it's going to extract all the parasitic capacitances. Now let's do the extraction to spice. Now let's see if it changed. It's extracted as inverter.spice. So if you look at this file, now we can see that after turn on the hierarchy, it extracted as dot subcircuit, and all the parasitic capacitances are extracted. And also make sure that this one, the pin order, are the same as what we see from here, which is from the test bench. If we open this one, so in the test bench netlist, we have all the voltage sources and then subcircuit. So we are going to substitute this subcircuit using this post layout simulation. Just make sure that the pin orders are the same. So as we did the layout, first we started with the layout. like port make 1, 2, 3, 4. So we did with this order. If during the layout, like for example, if you forgot or if you have a pin order different from your schematic, just change it from the text file to make sure that the pin order is the same. So we have these two are the same, VDD in out VSS. Okay. There's several ways to do it, but most in order to avoid any mistakes, I suggest that and also we're going to do both schematic simulation and post layout simulation. So I suggest that we already simulated this one, and the simulation results, let me show. If we go to the simulation results, will be saved here, .xschem simulations, and the simulation results are the inverter test bench.raw. Where's that I? Yes. So the simulation results, it's plotted in this file, and when we plot it, it takes the data from this file. Now, in order to do the comparison between schematic and post-layout simulation, I'm going to do, now this is already schematic simulation results, right? What I'm going to do is, I'm going to do save as this one. In the current folder, I'm going to save it as inverter test bench PEX, which means that parasitic extracted. Click OK. Now, in this test bench, I'm going to include the extracted netlist. In order to do that, okay, if I do the simulation, here if I do the netlist and the simulation, the simulation results now is saved as inverter test bench underscore PEX and row, right? And but this is still the schematic netlist. And in order to include that post layout netlist, first this symbol, we go to symbol, inverter symbol. For this one, click Q to open the property, and then here the type subcircuit we are going to change to primitive. Click OK, click save it, and let me open the new one. Open back that inverter test bench PEX. Now, if I do the netlist, it's going to be a little bit different. As you can see, the subcircuit is gone now. Let me open the subcircuit as well in order to make the comparisons. The inverter test bench. If I do the netlist here, oh, okay. Because I already did primitive for the same symbol, so that's why a subcircuit is gone. So in order to that, we need to come back to add subcircuit here. Subcircuit, save it. If I do netlist, what we can see that now it included the schematic netlist as subcircuit. And if we do the simulation, this test bench save the results and testbench.raw, and this is the schematic simulation. And then here, because we are using the same symbol, so I need to do it again here. Type to primitive, click OK, and then here, if I do the netlist, edit netlist, so now the subsocket is gone. If I simulate it, it definitely give me the error because there's no subsocket included here. Now, how do we include that post layout simulation? So in the here you just need to include that post layout netlist include. That's going to be projects test layout inverter spice. Just make sure that I didn't make mistakes here. Let me open as a new window. If I go to projects, test layout, that's gonna be inverter.spice. So this is the parasitic extracted netlist. So the directory is the same, projects slash the tilde sign, the projects test layout inverter spice. Okay, click OK. Now hopefully this does not give me any error. Do the netlist again. Now in the netlist, as we can see, it uses this include to include the post layout netlist. And then let me try simulation. Okay, great. The simulated without error. So now you can see that these results stored in this PEX.raw. And if I click, oh, okay, one thing very key important to make sure that this is post-layer simulation, the load waveform, you need to queue. Aha, you can see that this one is still giving me the schematic netlist, schematic waveform, not the post layout simulation. So we need to change this one. Is it tb dot? If I do it, oh, okay. It's supposed to be here as the name suggested. So here it should be underscore tb underscore PEX. So we need to extract the waveform from this simulation, post layout simulation. This is very important, otherwise we're gonna still see the schematic simulation. Click OK, save it. Let me run one more time, netlist, simulate. Okay, here, and also this is gonna be extract the waveform from this. Okay, now this is the post layout simulation. So how am I gonna do comparison? So as in our previous video, we already see that we have the external waveform, which is, if we come back to this post layout simulation, let's do the post layout simulation first. See the post layout simulation first. So external viewer, this GAW waveform viewer. From here, you can see that this is corresponding to inverter test bench PEX. So if you look at the V in and the V out, as you can see that this is the inverter, right? low corresponding to high, high corresponding to low. And then I need to do the open the schematic simulation from here, open. As we remember that is corresponding to this inverter test bench row, that is the schematic results. So I'm going to open this. It's going to open another window here, which is extract the data from this. So no need to plot the V in because the V in, the voltage source, the stimulus is the same. So I just need to grab this V out, up, grab the V, drag it to here. And the schematic is as red wire. Okay, we need to do zoom in to see the difference. Okay, I a little bit forget how to Z. Is it Z? Nope. Okay. If we zoom in, you can see that difference. The red corresponding to schematic, and the blue corresponding to the post layout simulation. And since this is a very simple circuit, there's not much parasitics, so they're almost the same, but when the schematic gets complicated, then you will definitely see more the simulation differences between schematic and the layout. So this is how we're gonna do comparison between schematic and the post layout simulation. Thanks for watching.